So we're looking at the function 1 over x squared minus kx, and they give us the derivative, which you should be able to find on your own anyway, but that's fine, k minus 2x over x squared minus kx squared. And they say let k equal 3 so that our function is 1 over x squared minus 3x. We want to write an equation for the line tangent to f at that point where the x coordinate is 4. So that should be really pretty straightforward. All right, if k is 3, we've got this function. We can find f of 4. F of 4 ought to be 1 over 16 minus 12, or just 1/4. And we ought to be able to find f prime of 4. So if k is 3, then we ought to have 3 minus 2 times 4, so 3 minus 8, over, what do we got, x squared? So 16 minus 3 times 4, 16 minus 12 is 4 squared, which is 16, so negative 5/16. And so our equation ought to just be y minus 1/4 equals negative 5/16 times x minus 4. Everybody good there with that part? That part was easy, I hope. Okay, and that was just worth 2 points. 1 point was for the slope. 1 point was for the entire equation. All right, for part B should have been pretty easy. Also, we're looking for relative min-max or neither at x equals 2. And so all we need to do first off is figure out what f prime is. And since we know that we're looking at k equals 4 with x equal to 2, we've got f prime of x, and if we plug in our k equals 4, that's 4 minus 2x over x squared minus 4x squared. And so obviously we know that at x equals 2, this thing equals 0, right? So that equals 0 at x equals 2. And so we do have a critical value at 2. The only other critical value would be something that made the denominator equal to 0, which would be 0. So we want to sort of keep in mind what's going on there. So we'll put on a 0 on our sign chart and a 2, and also a 4 would make the denominator equal to 0, which would make it undefined. So we really, when we check our values of f prime here on our sign chart, we got to check something between 0 and 2 and something between 2 and 4 to see if it's a max or a min or neither. So if you plug in 1 to your derivative, this becomes a positive in the denominator and a positive in the numerator, so increasing. Plug in 3, you get a negative over a positive, so decreasing. So looks like you have a relative max at x equals 2, or local max. Easy enough. Another easy 2 points there. That one was pretty straightforward as well, I hope. So 1 point. 1 point for the answer with the justification, and 1 point, I mean, I don't know why they would have, considering f prime of 2, showing that f prime of x is 2, or f prime of 2 is 0. They gave you a point for that. Yeah, local and relative max or min is the exact same thing. Sometimes they're called local, sometimes they're called relative. And then global and absolute max and min are the same thing. Global, absolute, relative, local, both, relative, local are interchangeable, and then absolute, global are interchangeable. So if you see either of those terms, it's the same thing. Good. All right. And then for part C, we want to find the value of k, for which f has a critical point at x equals negative 5. So we will just then plug in the value of negative 5 to f prime. So we end up with k plus 10 over 25 plus 5k squared. And looks like the value of k there would be k equals negative 10 from the numerator there, and then k would equal -5, but from the denominator, but k equals -5 isn't going to make any sense because if k equals -5 and x equals -5, then this is equal to 0 at k equals -5, x equals -5. And because of that, our original function isn't defined there, which means that that is not a critical point. Function has to be defined at the same at that point in the original function as our critical point. So we can't have a critical point at k equals -5. So just 1 point for getting the right value there. And if you put k equals -5, they probably wouldn't have given you that point. So that one's only 1 point, but a little bit tricky there because you might have come up with -5 also. Did some of you come up with -5 also? Just out of curiosity. I'll assume that since nobody said anything in the chat there, that means that you either nobody came up with it or you don't want to tell everybody that you came up with -5 and wrote that. So just make sure that the value that you get as a critical value doesn't make your original function undefined. All right, and then for the part of this that is actually like a little more difficult with the BC stuff, we got k equals 6. Oh, it does say find the value of k. I guess that's true. Yeah. It only asks for one value. Yeah. So that would clue you in that there should only be one. All right. So let k equal 6. So our function is 1/x² minus 6x. We want to find the partial fraction decomposition for f of x, and then we want to find the indefinite integral of f of x. So that should have been pretty straightforward, I hope. Also, you would have said that 1/x² minus 6x is the same as 1/x times x minus 6. And so we would have called that a over x plus b over x minus 6. And then we would just multiply the a by x minus 6, so ax minus 6a, and then plus bx should be equal to 1, giving us a equals, bx, a plus b equals 0, because there a plus bx is on the left and 0x is on the right. And then -6a equals 1, so a is -1/6, giving us b is +1/6. And then we would rewrite this as, so 1/x² minus 6x equals -1/6 with our x in the denominator there, and then plus 1/6 times x minus 6. So that's your partial fraction decomposition. And then they wanted you to find the indefinite integral of that. And so in order to integrate that, I would personally take out a -1/6 to just make this 1/x minus 1/x minus 6 dx. And then you just integrate, you get -1/6 natural log absolute value x minus natural log absolute value x minus 6. Just based on how we wrote it, plus a constant there. And if you wanted to, you could put the x over the x minus 6. And I think it looks like if you look at their scoring guide, they flipped them and brought the negative inside, but this answer would be fine. You could rewrite this as natural log of absolute value of x over x minus 6 with a 1/6 here, or sorry, with a -1/6 there plus c. That'd be fine. You could write it as, make the x minus 6 over x. You could write natural log, 1/6 natural log absolute value x minus 6 over x plus your constant, that would be fine. You could do natural log of the absolute value of the 6th root of x minus 6 over x plus your constant if you wanted. That'd be fine. I mean, there's a lot of different ways to write this. Yeah. So any of these, I mean, there's just a ton of different ways you could write this. You could have brought the 1/6 in and left the negative out. You could have done all kinds of things with it. So everybody good there? I feel like that was pretty easy, actually. That was a pretty easy free response question overall. That would have been one I would have hoped everybody would have got 9 out of 9 on if that was on the AP test. So you get 2 points for getting the partial fraction decomposition and 2 points for getting the correct expression. Any questions on that? So I wouldn't be too surprised if you see something like these 3 that we've done on the AP test this year. These are the only 3 that they've released that have been like this, but in the, I mean, I'm not counting 2020 because that was a weird year, but in the 2015 to 2019 tests, so in the 5 previous years, they've had, these questions were on 3 out of the 5 years, and they had never been on before. So I wouldn't be surprised if you saw something kind of like this show up this year. So luckily, I don't think they're that difficult. I think they're kind of one of the easier ones in general. Anybody have any questions on improper integrals or partial fraction decomposition or any of this stuff? All right. So now we're going to start looking at particle motion, and you'll note that this slide has 20 of these. These are very common. Sometimes they show up in the calculator, sometimes they show up in the non-calculator, sometimes they show up with graphs, sometimes they show up without graphs, right? More often than not, they don't have graphs, and I would say if you look through, more often than not, they are calculator questions. Like most of these are calculator, but there are a few that are not calculator questions. So particle motion, usually given some sort of parametric function. I have posted these on Google Drive, Nick. Yes, I did this morning. So they should all be up and available for you to look at. My guess is we're only going to really have time to go through one of them today, but I'll assign a few of them. They're just in the assignments thing. It's called Particle Motion FRQs BC. And so all of these, I believe all the ones I selected are specifically BC questions. And I don't believe, I haven't ever seen a particle motion on the BC test that only included AB material. So like there's plenty of AB particle motion questions, but they put the ones that only include AB material on the AB test, rather than sometimes, some of the free response questions will have only AB material on the BC test. These always end up with like a parametric in them or vectors in them. Did you find them in the Google Drive, Nick? Perfect. All right, so we'll start with this one. This is a non-calculator, and I will give you guys 15 minutes to work through it, and then we'll talk about it. And that'll be our basic little reintroduction to parametric vector type stuff with particle motion, and then have you work on the next like 2, 3, 4 of them this afternoon. So I'll set a 15-minute timer. Hopefully that will be plenty of time. Ready, go. So for part A, we want to find the position of a particle at t = 3. We're given a parametric, or we're saying that we got a parametric function, x of t, y of t, where dx dt is t squared plus sine 3t squared. And they give us the graph of y, which is 3 line segments. And we know that at t = 0, the particle is at a position of 5, 1. So first thing they want to know is the position of the particle at t = 3. So we are effectively needing to find the value of x of 3 and of y of 3. So y at 3 should be easy enough. The value of y at 3, this is just the graph of y. So it says these are line segments. So if we're going from 2, -1 to 4, 0, 3 must be at -1/2. Then to find the x coordinate of the position, we're going to have to integrate dx dt. So if we integrate dx dt, that means we should get the value of x, right, plus some constant. So what we're going to do then is integrate t squared plus sine of 3t squared. Oh, this was a calculator question. Dang it. Did I not? Ah, man, no. This was a, did I tell you guys this was non-calculator? Dang. Oh, boy. Okay. Yeah, as soon as I started going through here, I was like, you're not going to be able to integrate that. Ah, dang. I had it typed in for all the other ones. So just in my head, I said, this one must have been non-calculator. Nope, this one's calculator too. And now it says it is. All right, so we need to integrate this. And if we integrate this from 0 to 3, that should give us our displacement from 0 to 3. And we know that at t equals 0, it was 5. So our new position ought to just be 5, our initial, plus this integral. This would have made it really hard to do a lot of the parts of this, not having a calculator. So since this is all right here, this is displacement. And so when you integrated that and added 5 to it, you would have gotten 14.377. Then, yeah, that's fun times. So your position should have been 14.377, comma negative 1/2. Sorry about that. So you got 1 point for the correct integral, 1 point for remembering that you needed to use the initial condition because this integral was displacement, and 1 point for the entire thing. Everybody okay with that? Okay. Part B was asking for the slope of the line tangent to the path of the particle at t equals 3. And so that ought to just be dy dt at 3 over dx dt at 3. Dy dt over dx dt, or effectively dy dx at t equals 3. And so the dy dt value is just the slope of y, right? So slope at 3 equals dy dt at 3, which should be 1/2. That's the slope of rise 1, run 2, so slope of 1/2. And then over dx dt evaluated at 3, which is 9 plus the sine of 27, which is, I bet that's what you guys wrote as your answer. But if you approximate that out using your calculator, you end up getting 0.05. And you would have gotten 1 point for part B, just for correctly getting that value. Everyone good with part B? All right, and then we want to find the speed. And so to find the speed, speed is the absolute value of the velocity, right? And the absolute value of the velocity is just the magnitude of the velocity vector. And the velocity vector should be dx dt, comma dy dt. And so if we're trying to figure that out at 3, all we've got to do is figure out the magnitude of the velocity vector, which is the square root of dx dt squared. And so we'll call that dx dt at t equals 3 squared plus dy dt at t equals 3 squared. And, we have all these values. Dx dt at t equals 3 is just that value we got before, square root of 1 over 2 times 9 plus sine 27 squared, and then plus dy dt at 3 was a half, so plus 24. And that's probably what you wrote down as your answer for this one, but that approximated out to be 9.969. And that one is worth 2 points, one for getting the right expression, so magnitude of the velocity vector, which is just the square root of 2 squared.
9 plus sine 2 sine of 27 for the dx dt part.
Say that again.
So for the dx dt, should it be 9 plus sine 27?
Yeah, it's 2 times 9 plus sine 27. I just put the 2 from it's 1/2 over, right, our dy dt value here was 1/2 over 9 plus sine 27. So I just put the 2 into the denominator. Oh, it's just 9 plus, oh, I'm just, never mind. Yeah, 9 plus sine 27 squared. My fault. Yeah, I see what you're saying. Yep, I just looked at what I had written over there thinking it was dy dt. That's my fault. Just 9 plus sine 27 squared. I just looked at the whole thing, which was dy dx. All right, everybody good there now? Now I was not understanding what Adrian had wrote, that I wrote dy dx. I'm like, it actually, my handwriting's bad, but none of them look like dy dx. But now I see what you meant. Yeah, dy dt dx dt. Yeah, there we go. All right, everybody good with part C? Hopefully. Okay. All right, and then part D. I'm probably get a new page for part D. Part D just wants the total distance traveled by the particle from 0 to 2. And so the total distance traveled, if you are looking at a velocity vector, should just be the integral of the square root of the velocity vector, the x component squared plus the y component squared. So our total distance traveled should be an integral this time at 0 to 2. And it should be the square root of dx dt at t equals 2 squared plus dy dt at t equals 2 squared dt. And this time I'll do my best to actually plug these things in properly. So our value of dx dt at 2 should be 4 plus the sine of 12 with nothing else attached to it. And then our value of dy dt at t equals 2 yeah, Yeah, Delphine. So the total distance traveled is always, it's just the integral. I mean, it's just the integral of the magnitude of the velocity vector. It's the integral of speed is always total distance traveled. So maybe if you remember that from last year also, and if we had velocity has direction, so the integral of velocity gives you displacement, but the integral of our sorry, I lost my train of thought. Integral of velocity gives us displacement, so integral of speed gives us total distance traveled because velocity has a direction to it, whereas speed does not. Does that make sense? All right, cool. And so then as we look here, so if we're trying to do this value for dy dt at t equals 2, well, that's a problem because for multiple reasons. One, specifically at 2, the value of dy dt is it's not got one specific function to represent it. And so we have to take a look at each piece of this separately. So we're going to have to do 0 to 1, and then we're going to have to do 1 to 2 separately for this. So if we go 0 to 1, square root of 4 plus sine of 12 squared plus the value of the derivative, so the slope from 0 to 1 should be negative 2. And then, shouldn't be, gosh, I'm sorry, I'm out of source today. This should, we don't plug this. This is just t squared. We don't plug these things in because we're doing the integral. Was it 3t squared? Is that what it was? T squared plus 3 sine 3t squared from 0 to 1. And then an integral from 1 to 2 of t squared plus sine 3t squared plus the value of the slope from 1 to 2, which is 0 for this piece of it, so plus 0 squared dt. And that's what you need to integrate. That's sorry, I made a mess of that one. I'm a little out of sorts today. I don't know what's going on. So that looks atrocious. We're going to rewrite that. Does that make sense or no? I messed this up horribly. So it's the integral of dx dt squared plus dy dt squared from 0 to 2. We had to break it up to 0 to 1 and 1 to 2 because we have different values for dy dt here. Dx dt obviously is changing too, so I don't know why I plugged in a 2 to that because we're integrating from 0 to 2, so we got to do t squared plus sine 3t squared as the value inside the integral. Yeah. Sorry, does that make sense or no? And then you get a value for that when you approximate it out, which is 4.350 is our total distance traveled. And they gave you 1 point. 1 point for this, 1 point for writing out both integrals, and 1 point for the answer. So yeah, is that good? Does anybody have any questions on that? After I went through and screwed it up.